Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 10 students who are working on the year-end summative. It's question 13 from that summative, and it's from the trigonometry section.
Okay, it says two wires are supporting a vertical tent pole as shown. So here's the tent pole, and then I've got this wire here, 2.2 meters in length, and another wire 2.8 meters in length. And the angle between those two wires is 80 degrees. So part A says, how far apart are the wires fixed in the ground to the nearest tenth of a meter? So I want to know what this distance is here. So how are we going to do that? Well, don't get fooled by the fact that it looks like there's right-angled triangles. There are right-angled triangles, but we don't know nearly enough information to use that. If you look at an individual right-angled triangle, I know absolutely nothing about this triangle except for one side and the opposite angle being 90 degrees. I don't know which portion of 80% belongs to this angle, and obviously I can't just say, well, it's half, because that would make no sense since these wires are at different lengths from each other. So therefore, I can't use straightforward trigonometry. So what can we do? Well, we therefore have to use either the sine law or the cosine law. So have a look at this triangle. And you always want to try the sine law before the cosine law. I think of cosine law as like, if nothing else works, then you do cosine law. So I have a side. Do I know the opposite angle? Nope. Here's another side. Do I know the opposite angle? Nope. Here's an angle. Do I know the opposite side? No. So there's no way that I can use the sine law, because to use the sine law, you need one side and its opposite angle to both be known. So therefore, we have to use the dreaded cosine law. That's not so bad. Okay, so let's go to the next page. So here's my triangle. We're going to call this 80 degrees because we were told it was 80 degrees. This is 2.2. Oops. This is 2.2. This is 2.8. Did I get everything? Yes. Now, personally, I don't like dealing with any sort of triangle if I can't name it. So I'm going to call this A, B, and C. And so therefore, this side is little a, this side is little b, and this side is little c. And the side that I'm looking for is A. So therefore, I'm going to set up the cosine law like this. A squared equals b squared plus c squared minus 2bc cosine A. So again, make sure you understand how the cosine law works. This side here matches the angle over here, and the other two variables are the other two sides of the triangle. So I'm looking for little a. I have B, C, and I know angle A. So let's go ahead and do the math. Okay, so A squared equals B squared plus C squared minus 2BC cosine A. All right, so obviously make sure your calculator is in degree mode, and then just start doing the math. So let's see, 2.8 squared is 4.84. 2.2 squared minus, so I'm going to multiply all of these guys together. So that would give me 12.32, and I'm going to calculate cosine 80. Again, make sure you're in the proper mode in your calculator. Nothing's worse than doing a question correctly, except for your calculator messed you up. So now what do I have? So 4.84 plus 7.84, that's 12.68. Minus, here I'm going to do multiplication. 12.32 times 0.0736 is 2.14. So I'm rounding a little bit. So a squared is equal to 10.54. So square root both sides. I get a value of 3.3 meters when I've rounded correctly to the first decimal place. Good. Does that make sense? It sure does. So, if I got an answer like 30, I'd be a little concerned, because no diagrams are never perfect and are never intended to be measured. There should be some sort of sense of size references. So, this is roughly 80, and this side here is a little shorter than this side. So the fact that this is 3.3 makes a lot of sense. Okay, so let's look at part B. Find the angle that each wire makes to the ground to the nearest degree. So I want to know this angle, and I want to know this angle. So let's redraw all the information we have. Ooh, let's be a little neater this time. Boom, boom, boom. Ooh, fancy. And we had labeled this A, B, C, and therefore this is little a, little b, and little c. And we know the following values. We know that this is 80 degrees. We know that this side is 2.2 meters. We know that this side is 2.8 meters. And we've just found that the length of A is 3.3 meters. Okay, so what can I do now to find the measure of angle B and the measure of angle C? Well, now that I've calculated from part A, I now have an angle and its opposite side. So I have one partnership here, and that means I can now use the sine law. So sine A over side A is sine B over side B, and that's sine C over side C. And so we'll take this portion first, and let's solve. So sine A, so that would be sine 80 over 3.3 is sine B, and I don't know what that is, but that side B is 2.8. So now this is a calculator question. Sine 80 degrees is 0.9848. And so now I'm going to cross multiply. So 2.8 times 0.9848 gives me 2.7574. And 3.3 times sine B, well, is just 3.3 times sine B. So divide everything by 3.3 because I'm trying to isolate the sine B portion. That gives me 0.8484. So that's sine B. So how do I get B? Well, this is where it's going to sound weird. You bring sine to the other side. So, that's not proper vocabulary at all, but it's kind of what your brain should be thinking about. I need to isolate B, and right now I have sine B. And the way to get rid of sine B is by doing this. Inverse sine. So inverse sine is the exact opposite of sine. And on your calculator, it's probably second function sine. So here, inverse sine and sine eliminate each other. I'm left with B, and this I punch into my calculator, and I get 58 degrees for the angle of B. So now I know that this is 58 degrees. Now to find angle C, you could, again, use the sine law, right? So this time using sine A over A and sine C over C. But we also know that the angles in a triangle add to 180. So let's just use that fact. So 180 degrees equals 80 degrees plus 58 degrees plus angle C. So doing that math, I get 42 degrees equals C. So there we go. Now, if this was a test or something for marks, you might want to use the sine law to find C, and then just make sure you have the right answer by checking that they add to 180. But, if you're confident in your work, you're confident in your work, right? So it all depends. So I hope that helps. That's a pretty straightforward sine law, cosine law question. Ask for help if you need it. Thanks. Bye.